Today, I'm going to tell you something about the age of our universe and how early dark energy can be a solution to the Hubble tension problem, which relates to the expansion rate of our universe. Before my talk, I would like to ask you a question. Why is the night dark? You might answer it's because the Earth is rotating to the backside of the sun, so it does not receive any light from the sun in the night. That's right. But if you agree that our Earth is not the center of the universe, and if you also assume that the universe is infinite, then you would find that the Earth should receive all the lights from the other stars. So eventually, our night should be as bright as our daytime, as shown in this GIF, if there are infinite many stars in the sky. So why is the night dark? This is the so-called Obus paradox. A lot of people try to solve it, and one of them is a famous writer, Alan Poe, who once lived here in Philadelphia. He wrote in his essay Eureka in 1848, suggesting that a finite universe could be a solution. This idea inspired the following scientists to build more robust and scientific models and use observations to verify their models. But the story does not stop here. In 1924, the American astronomer Edwin Hubble discovered that the galaxies are actually getting away from us, just like the raisins in the dough. When the dough expands, the distance between the raisins are getting larger. It is the same for our Earth and the nearby galaxies. Hubble also discovered that the further the galaxies are away from us, the faster they are moving, and their velocities are proportional to their distance to us in a roughly linear relationship. The slope of this line is the expansion rate of our universe. We also call it Hubble constant. A larger Hubble constant means a faster expanding rate, which makes the universe younger. And from this, people could estimate that the age of our universe is about 14 billion years old. This tells us that our universe is not static. Instead, it is an expanding universe. This directly leads to the idea of the Big Bang theory, because if we find an expanding universe looking forward in time, then we should find a shrinking universe if we look backward in time. So there has to be a point in the past that all the galaxies are close together. So the universe was very hot and tiny and dense at that time, and then start to expand from that. This is the idea of the Big Bang. You can imagine it is very bright at that time, and there are a lot of photons trapped in the hot plasma, because whichever direction it goes, it will meet the other particles. As the universe expands and getting cooler, the electrons and protons bond together to form hydrogen, so they cannot hold the photons anymore. Thus, photons started their lonely journey and traveled through the universe without any obstacles. If nothing else happens, they should reach us no matter in daytime or in night. So why, again, is the sky dark at night? The answer lies in the fact that when light travels in the expanding universe, their wavelengths got stretched, just like the distance between the regions. We also know that our human eye can only see a very narrow range of light. So when the wavelengths are longer than the most red thing that we can see, we just simply can't see them. So that's why our night is dark. In fact, they are redshift to the microwavelengths. And in 1964, Penzias and Wilson discovered this cosmic microwave background. We also say it CMB. They really detected those ancient photons from the very beginning of the universe. Cosmologists built the standard cosmology to explain the history of our universe. And from the CMB data, they obtained the expansion rate of our current universe, which is also the Hubble constant. Because the information is from the very beginning of the universe, we call it early measurement, compared to what Hubble found, which uses the data from the local late-time galaxies. These ancient photons seem to tell us a smaller expansion rate of our current universe. This is the so-called Hubble tension problem, a tension between the early measurement and the late measurement. In 2005, both early and late measurement tells us roughly a similar age of our universe. But as observation getting more and more precise, they seem to favor different values. In this most up-to-date summary of the observations, we can see that the late time measurement favors a larger expansion rate, while the early time gives us a smaller Hubble constant. Some of the astronomers might still treat it as some error in the data or the data analyzing skills or the statistical errors. But theorists like me are very excited to see the possibility that this Hubble tension could be a hint to new physics, something we have to modify on our standard cosmology. Early dark energy is such a modification. What does it do? Let's go back to the recent dough analogy again. So we know that we need to add some yeast into the dough to let it ferment. But we also know that if it's in winter and it's cold, the yeast does not grow as fast as in summer. So what can we do? We can add a little bit baking soda inside of it. Well, we know that when baking soda meets the acid, they react super fast and create a lot of bubbles to expand the dough. So, and also we know that because this reaction is very fast, it stops very soon after this. So our early dark energy is something just like the baking soda, an extra component we add into the standard cosmology to lift up the expansion rate a little bit and decay away very soon after that. Because it decayed very quickly, it's irrelevant in the later cosmic history so that it does not ruin the observations that much, but it's very successful in terms of solving the Hubble tension problem. However, the fundamental physics behind the early dark energy is still unknown. It is actually very tricky to make this particle theory be consistent with both mathematics and gravity theory. This is a challenge to theorists that we are taking in our recent research. The story of the age of our universe is still ongoing, and we have a long way to go. Thank you.